We're here at gotomath.com. Click on the calculus. Let's go down to hyperbolic functions and let's click on 4.2, or you could actually click on that button if you want. But it gives us a random problem between 4.1 and 4.2. Alright, so here we go. We got 3 hyperbolic sine 2x plus 5 dx. Give me a second here and let me write that down. Give you a second. Maybe you want to write it down. Okay, I got it. Find the indefinite integral. Well, I mean, that's basically what that says there. Alright, let's bring up the whiteboard. Now, if you followed me through some of the earlier problems in the derivative section, applications, I use different colors. I don't know, I've been kind of sticking with one color on this whole integration section. I guess it's working out. I finally found a decent board to work with, canvas to write on, and that's supposed to be a 2 there. So let's write, or wait a minute. Oh yeah, okay, never mind. 2x, I rewrote that 3 is what it was, plus 5. That's what I had written down on a piece of paper. Dx. Okay. So let's go over here and write down what this integral is actually equal to. So if we had sine h of u, right, du, u is actually a function. Well, I mean, I guess I shouldn't say that. I think I said that in earlier videos, and now that I think about it, this is du right here, so technically that's not true, but it could be thought of. See, this here is thought of as a function here, okay? It would be, yeah, we couldn't really name the function u of u, but anyway, I probably shouldn't have said that. I just now realized that. Let's see, cosine, but maybe you'll see what I mean here in a minute. Cosine h of u. You gotta, man, when you're doing math, you gotta really be precise in what you're saying. You know, I mean, everything has to be precise in a true statement. Okay. So as you can see, the integral of sine, now with hyperbolic sine, is equal to cosine. Now remember, if it was just sine we were doing, it would be negative cosine, but it's positive cosine here. Hyperbolic. Okay. But in this particular case here, we can't do that. We got to use u substitution because this function here is, well, it's not just x. If there was an x in here, then we could just run straight and do that, but we've got something other than x in here, and that is we're going to let this be u. So you should be getting down your substitution by now. And the derivative of this is 2dx, 2dx, okay? Alright, well, we don't have a 2 out here, we got a 3, and what I'm going to do is I'm going to go ahead and just pull that 3 and get it out of the way outside the integral sign, and then what we'll do here is we'll just rewrite this over here. So this becomes a half. We solved for dx in this problem. Du is equal to dx. Now we can substitute, right, this dx for this stuff here, right? And what do I do with these guys here, this coefficient? I always take it outside the integral sign. We take it outside the integral sign, all right? So now we have 1 over, oh man, I want to write that 1 over thing again. I did this in the last video. I don't know why I got the 1 over deal on my mind. So I'm going to rewrite the sign. H of, so all this stuff here is u. And don't get this u mixed up with this stuff over here, okay? Alright, I keep saying that because it might be confusing if you look at that, you know, that over there. Okay. All right, looks good. So the integral of sine, hyperbolic sine, integral is cosine. So we go ahead and write that. Now let's not forget about this stuff. So this is 3/2 cosine h of u plus c. But then we need to go back and substitute, get everything back in terms of x again. And so we have u is 2x plus 5 plus the constant, right? 3/2 hyperbolic cosine of 2x plus 5. And of course, I want to look at this, make sure all this is good, looks good, everything looks good. We're at gotomath.com. Come on by, check it out. See